Okay, last lecture we have learned how to find out eigenvalues and eigenvectors for a given matrix, and maybe after I will ask you to find out the eigenvalue and eigenvector of this matrix. At the moment I am not telling you, so don't find values and eigenvectors of A. Now let us learn some tricks of finding out eigenvalues and eigenvectors of some simple matrices. First, suppose the matrix is given to you which looks like 300, 070, 008. A. Find eigenvalues. Now find eigenvalues and eigenvectors. So notation for this of A. Notation for this square bracket is capital F. Okay? Now, this is a special matrix where all non-diagonal entries are 0, and therefore, now by procedure you must have got those eigenvalues. Lambda 1 is equal to 3, lambda 2 is equal to 7, and lambda 3 is equal to 8. But then you need not have to do any calculations for such kind of thing. These values are the eigenvalues then and there itself. Why? Because and if you multiply this vector by 100, okay, so what is 100 doing? 100 will always keep only the first vector. Now this is 3 by 3, this is 3 by 1, therefore you will end up getting 3 by 1. And which one will survive? Because these are two zeros, 3 into 1, 0 into 0, 0 into 0. So you will end up getting 300, right? And 300 is definitely a multiple of 100, and therefore you can always write this as 3 times 100. So if this is your eigenvector, then you retrieve the same vector back by multiplier as a 3. So 3 is your eigenvalue and 100 is your eigenvector. Here it will be 0, 1, 0. Only second column will survive. Okay, and here only third column will survive with the multiplier that you have 0, 0, 1. Therefore these are the eigenvectors. Let us call them as v1, v2 and v3. These are the eigenvectors and values if you happen to have a situation like this. It is direct, there is no. Now orally, instead of doing these calculations also, orally we can write 1 here, 0, 0. That means you take this first vector, column vector 1 times, second column vector 0 time, third column vector 0 time. Are you producing 300 same vector? Yes. So the linear combination that you are going to really write is to be done here in small letters. Okay, we will practice that, and that will save a lot of time for finding out the eigenvector having got eigenvalue. Next problem. Have you understood this? If you have a special entries. Now, what is the conclusion out of this? In any given matrix, if your principal diagonal entries, are non-zero and every other entry in that column is 0, then that is the eigenvalue which is available. Okay, suppose, okay, we will take another example. Now, problem number second is second type. I mean, we will eventually combine all these types to solve that pi by pi problem. But the second type of matrix that I would like to give you and ask you to find out eigen values is 9, 12, 10, 807. Okay. Find eigenvalues and eigenvectors of A. Okay, maybe I will change the question a bit because finding the remaining two might be little difficult, but you will get the first eigenvalue very quickly. Lambda 1 is equal to 12 is going to be your eigenvalue, and corresponding eigenvector is going to be 0, 1, 0. Okay. Now we know 3 by 3 there will be 3 eigenvalues if the matrix is good, out of which if you could find out one, then remaining two are not going to be that difficult. Basically, the trace of the matrix will give you sufficient hint. Sum is 14 plus 12, out of which 12 is gone. Therefore, lambda 2 plus lambda 3 is going to be equal to 14. And if you find out the determinant of this matrix, I mean, see, there is no shortcut for finding out the remaining two. Maybe you will have to at least work hard for finding out the lambda 2 and get the corresponding eigen vectors. But this is very easy. This will work. Now, 0, 1, 0 will produce 12, 0, 12, 0, which is 12 times this eigenvector v. Okay, that is where we stop for this problem. Finding the remaining two is going to be difficult. I mean inward. Next type where we can have some shortcut is at least find out one eigenvalue and one eigenvector, or maybe one eigenvalue in this case. 2, 3, 8, 12, 13, 14, 0, 0, 7. Now, the property that you are required to know, which maybe we will prove later, that eigenvalues of A and A transpose are same. However, eigenvectors may be different. Okay, if this statement is true, which we will try and prove it eventually, but at the moment you can use it, then you can guess that the transpose of this is going to be 2, 13, 7 in the right places wherever they are, and the last column would become 0, 0, 7, and with the earlier trick that we have used, that it is in right position along with other zeros, lambda 1 is going to be 7. Of course, this is the additional information that you are getting by observing the matrix. You can find out all the three, lambda 1, lambda 2, lambda 3, by the first method that we have learned. 2 minus lambda, 13 minus lambda, 7 minus lambda, get the polynomial in lambda, solve it, you will get all three. But in this case, because these two entries are 0, if you take transpose, the lambda value, the eigenvalue of A transpose is definitely going to be one of them, it will be 7, and therefore A also will have eigenvalue 7. Okay, then next time A is equal to 6, 2, 1, 5, 2, 2, 7, 3, minus 1. Should I ask you? Yes. Just find eigenvalues, not vectors. Find eigenvalues of this matrix A. Okay, let me get that polynomial also. 6 minus lambda. Can somebody tell me degree 3 polynomial that you got? Lambda. बोलते सांग.
Lambda cube minus 7 lambda square minus 19 lambda plus 9.
Plus
9.
determinant 9 है का त्याचा? minus 9 आहे. Determinant जी value आहे ती इथे. Okay, so suppose if you have this polynomial with you, then unless you have first root, you will not be able to decompose this polynomial into factors. So the trick here is, now you observe the summation of all the entries in each row is 9. Okay, summation of all the entries in each row is 9. Therefore, if you take one of this vector vertical plus one of this vector vertical plus one of this vector, you will get vector 9, 9. Is that right? And therefore, what you can say is 9 times 1, 1, 1 is 9 is your lambda 1, and this is your eigenvector 1, which is available with us because the summation. Now vector multiplication, you need to imagine first 6 into 1 plus 2 into 1 plus 1 into 1, 9. 5 into 1 plus 2 into 1 plus 2 into 1, 9. 7 into 1 plus 3 into 1 minus 1 into 1 is 9. 9 after multiplying by 1, 1, 1 to this matrix. Therefore, value of one of the values, eigenvalues is 9 and its corresponding vector is 1, 1, 1. So if you substitute 9 in this case, I mean lambda minus 9 is a factor, definitely you will get, because 9 is one of the eigenvalues, you will get lambda square, 9 lambda square minus 2 lambda, and you end up getting 18 lambda. You have 19 lambda with you, so
plus 2 lambda.
Wait a minute, huh? Minus 9 lambda plus 2 lambda. So 9 into 2 minus 18 minus 1. So this is what is your factorization, and therefore second lambda 2 and lambda 3 is going to be minus 2 plus minus under root b square 4 plus 4 upon 2. These are the two remaining lambda values, which is minus 1 plus minus 8. So 2 is gone, root 2. Okay, so the first lambda value is available because the rows add up to the same value. That is the trick which I want to bring it to your notice at this stage. Next. Rows add up to these lambda values, therefore you get lambda 1. So now if I give you the next matrix A where 3 to 2, 5 to 0, 6, 3 minus 2, what is going to be the first lambda value? Lambda 1 is going to be, see again, 7, 7 and 7. So lambda 1 is going to be 7, but really here it is summation of columns. So 1, 1, 1 is not going to be the vector. Lambda 1 is going to be the 7 value, because transpose lambda values are same but vectors are different. Therefore you will get first eigenvalue, and then if you put this in your cubic, you should be able to get the remaining two eigenvalues. So This is same as what works for rows. If it is given for columns, then you should take transpose and get the value of lambda. Next thing is, suppose I give you matrix A 1, 2, 3, 2, 4, 10, 20, 30. Now find out eigenvalues and eigenvectors of this. It is a special matrix. So standard procedure, by that you should at least get 1 minus lambda, 2, 10, 2, 4 minus lambda, 20, 3, 6, 30 minus lambda. This determinant must be equal to 0. So if you expand, you will get cubic in lambda, which you should try to solve and get all lambda values. Now, so what is the cubic that you are getting this time? Lambda cube minus 35 lambda square. Then 0 is equal to 0. This factorizes to lambda minus 35 into lambda square is equal to 0. So eigenvalues are lambda 1 is equal to 0, lambda 2 is equal to 0, and lambda 3 is equal to 35. So these are the three values. Are you getting this equation? Determinant is supposed to be 0 and sigma 2 also is supposed to be 0. Sigma 2. Check whether you are getting this. It should be like that. Now repeat eigenvalues, that to 0, is obvious because these columns are not linearly independent, they are dependent on each other. 2 times this column, first column is second column, 10 times first column is third column. So because there is only one column and remaining 2 columns are dependent on the first, so for all practical purposes, if you take any, now here what is going to be the determinant 3 by 3? 0. If you take any subdeterminant which is 2 by 2, what will be its value? Any subdeterminant you try,
0.
1, 2, 2, 4, answer is 0. 2, 3, 4, 6, answer is 0. Any subdeterminant, 1, 10, 3, 30 is also 0. So all subdeterminants which are 2 by 2 are also 0. And the last one by 1 determinant is not equal to 0. Okay. So let me introduce one more terminology. This matrix rank is 1. Matrix dimension is 3 by 3 and its rank is 1. Rank is 1, that means the order of non-vanishing subdeterminant. Rank is order of non-vanishing subdeterminant. Okay, and this rank of the matrix eventually will help us to find out the dimension of solution set, but that discussion we will do later on. Right now, because the rank of the matrix is 1, the given matrix is 3 by 3, and therefore if you really try to row reduce it by the method row reduced echelon matrix that we did, 10, you after reduction you will get this. Okay, so there are actually two independent variables, I mean two pre-variables, and only one variable which will depend on the two. Therefore, the dimension, if at all this matrix is used for forming a vector equation or a matrix equation, say for example 1, 2, 3, 2, 4, 6, 10, 20, 30 times xyz is equal to some matrix b1, b2, b3. Okay, now if you row reduce this and if you are expecting some solution out of this system, then of course your b2 and b3 after row reduction should be 0, 0. So let me write down b1, b2. Suppose b1 is 5, then b2 is 10 and b3 should be 15. Then and then only you will end up having solutions to this particular system, because the moment you row reduce the last two rows, you are bound to get 0, 0 here. If there is any other number at any one of the two places, then solution set does not exist. Okay, but then if it is 5, 10, 15 in RHS, yes, of course solution set exists, and your row reduction is going to look like this. Okay, and then what we will conclude based on our first lecture, you can take any value of z, you can take any value of y, and your x value will depend on y and z. So x is equal to 5 minus 2y minus 10z. So 5 minus 2y minus 10z is going to be your solution set. So if we look at the solution set now, there are two free variables. This is free, this is free. So the size of solution set, the dimension of solution set is dimension of matrix. Here it is 3 by 3. So it is expected that it is n by n. Suppose it is a square matrix, then n minus rank of the matrix is dimension of solution set. Okay, so in this case our dimension of solution set is two dimensional, and as far as eigenvalues are concerned, we have got 0, 0 repeat root, 0, 0 and 35. So 35 is a non-zero good eigenvalue. So for 35, if we wish to find out the eigenvector, for 35, not this, this one, then you will observe that 1 times first vector, 2 times second vector plus नाही काय करायचं. Okay, now okay, we will have to find out using 35. However, now let me show you quickly how do you get corresponding eigenvalue vectors for lambda is equal to 0. Okay, so let us go to this matrix. If my lambda value is 0, then essentially if you take 2 of this and minus 1 of this, 2 of first vector and minus 1 of second vector and 0 of third vector, we will get, let us write it again, 1, 2, 3, 2, 4, 6, 10, 20, 30. What I am proposing is take 2 of first vector, minus 1 of second vector and 0 of third vector. If you multiply, let us find out what do we get. 2 into 1, 2 minus 2, 0, 0. 2 into 2, that is 4 minus 4, 0. 6 minus 6, 0. So you get 0, 0, 0 vector. Correct? 0, 0, 0 vector. So that means for eigenvalue 0, you have this vector which is your eigenvector. So lambda 1 is equal to 0 and its corresponding vector is 2 minus 1 0. Okay, so if you multiply by 2 minus 1 0, you get 0, which is our ax is equal to lambda x is being satisfied, and x is not 0. X is not 0. 0 0 0 entries are not there. Okay, so if you want to get one more, because that is why I was explaining you what is the dimension of solution set. Because our dimension of solution set is 2, which is very much visible here. This is free and this is free. The two eigenvectors that we will get, one of them we have already got, and we will get one more. The linear combination of these two vectors will give you the null space. I will explain what do we mean by null space later on, but essentially it is null space is the space where every vector in that space is going to be the solution of your system of simultaneous equations. Okay, so I will explain null space little later, but then because the dimension of solution set is 2 here, we are supposed to get two linearly independent vectors in your null space. We have got one as 2 minus 1 0, and now if we look at the original matrix again and can get something. Okay, if we take, now let us take first and third, or yeah, first and third, then 10 times first if I take, and minus 1 times third if I take, and 0 times second, I will get 0 vector. Let me write it. Okay, 1 2 3 1 2 3 2 4 6 10 20 30. We have decided to take 10 times first vector, 0 times second vector, and minus 1 times third vector. We are going to get 10 into 1, 0 into 2 minus 10, 0, 0, 0. Okay, so lambda 2 is equal to 0, and the eigenvector is 10, 0, minus 1. Okay, and now using these two, say alpha times 2 minus 1 0 plus beta times 10 0 minus 1, you can create infinitely many vectors which will be producing eventual zero vectors here. Eventual zero vectors. We will go back to that little later. But essentially for lambda 1 we got one eigenvector, for lambda 2 we got another eigenvector, and now it is time to find out what is the eigenvector for 35. So for 35 we will have to do little work. 1 minus 35 is minus 34, 4 minus 35 is minus 31, 30 minus 35 is minus 5. Remaining entries stay like that only. Now 2, 3 and 6. Okay. Now determinant of this is supposed to be this is what is the, we know already 35 we have deducted, so this is what is the matrix that we have after subtracting lambda I times basically our xyz should produce our 35 times xyz. That is what is the idea. Okay, and therefore we are supposed to get x and z. So it is a little difficult, so for that you need to do some row reduction here. Once we row reduce it, we will come to know which vector, vertical column vector, is to be added in what proportion, so that we get x comma y comma z, or maybe 35 times x plus 35 times y plus 35 times z. So let me just do it, not complete systematic row reduction, but suppose I consider 10 as my, I mean we are not supposed to call it as pivot, but suppose first row I keep as it is, minus 34, 2 and 10, and we want to make this entry 0. So what do we do? 2 times first row is to be subtracted from second row. So minus 35. And what is this? Adusaster minus, this is 70. Is that correct? Then I take 3, 6 minus 5. I have just made 1, 0. Now let us make one more 0 there. Suppose I want to make 0 here, then I have to divide the original first row by 2 and add 0, 0, minus 34, 2, 70 minus 35. Now divide by 2, add, divide by 2, that is 1, and add, that is 7, divide by 2, 17 and 34, so minus 17 plus 3 is minus 14. Is that correct? Now you can see that these two entries, they are double of each other, and therefore, can you see this? This is 70 is, I mean, minus 2 times 35, and minus 14 is minus 2 times this. So if you take first column 1, second column 2 times, because they are proportional to each other. This is twice of this. So what is this now? So minus 34 plus 4, that is minus 30, plus 30 is equal to 0. Do you understand? Minus 34 plus 4, that is minus 30, plus 30 is equal to 0. So we could achieve the first entry 0. Let us see if remaining two entries also become 0. 70, 70, 0. Yes. 14, 14, 0. So our eigenvector for 35 is 1, 2, 3. Now without getting into much काय चाललंय, बरोबर चाललंय? हा,
सर बरोबर.
बरोबर आहे ना? इथे आता मी काय लिहू? 1, 2, 3. So while taking these three, you are supposed to check that all of them are producing the, because this is non-zero. This whatever these numbers you are taking, all of them are. See, if we take all these three numbers 0, 0, 0, then of course we are going to get 0, 0, 0. Here we are not supposed to take these three numbers 0, 0, 0. At least one of them should be non-zero, and hence we get the third eigenvector. So lambda 3 is equal to 35, and eigenvector is 1, 2, and 3. Okay, so the system is complete, and we have demonstrated if there are repeat eigenvalues, then what? I have already explained here that if there are repeat eigenvalues, then still you end up getting two different eigenvectors, because the repetition of eigenvalue, that means your determinant 0. In fact, it is 2 times 0 in this case, because only one particular column is defined and remaining two are linear combinations of them. Therefore, the third, I mean, here you will find that sigma 1 term is absent and constant term is also 0. The determinant matrix is 0. Okay, I hope you are understanding what we are saying right now. I am basically touching upon the tricks and techniques to find out eigenvalues quickly, and if it is possible, finding out eigenvectors also quickly. So let me give you next problem, next assignment. Suppose 2, 8, 0 5, 8, 0, 1, 2, 10. Suppose this is the matrix A which is given to you now. Sorry, not 10. So that चुकीच्या entries घेतोय. 2, 8, 0, 5, 5, 0, and 1, 2, 7. Suppose this matrix A. Now using the earlier tricks and some extra knowledge that you have, find all the 3 lambda values and their corresponding vectors. So my notation is find eigenvalues and eigenvectors of this. Now, first 2 eigenvalues are very easy. First eigenvalue is 7 and its corresponding vector is 0, 1, 1. Rows add up to 10, therefore second eigenvalue is 10 and its corresponding vector is 1, 1, 1. Okay, will give you 10, 10, 10 once multiplied by this vector to this matrix. And therefore now the trace of the matrix is 14, 14 is trace, and you have already got 7 and 17, therefore lambda 3 is equal to minus 3. Okay, so for lambda 3 which is minus 3, we need to find out the vector, and let me show you the trick. So after subtracting lambda, the matrix that we will get is 5, 8, 0, 5, 8, 0, correct, and 1, 2, 10. Okay, now you need to manage, because these two guys are zeros. You take 8 times this and maybe minus 5 times this, that will add up to 0. 8 पंच 40 minus 40. Second row is also same. Now the third row, 8 minus 10, you end up getting minus 2, which you want to make it 0. So minus 2 plus 2. So these are the numbers which will produce all the 3 components in RHS equal to 0 with this matrix. Okay, and therefore with this matrix, the original matrix, we will have 8 minus 5, 1 upon 5, which is 40 minus 25, 1. This vector will produce 120 minus 120 plus 75 and minus 3. Maybe you can cross check that. 280, 550, 127 multiplied by 40 minus 25, 1. Okay, 40 into 2, 80. 25 200 and 9. 25 minus 100 minus 120. First entry. Minus 200 plus 80. Correct. Second entry, 200 minus 125 is 75. And third entry, 40 minus 50, that is minus 10. 40 minus 50, that is minus 10, plus 7 is equal to minus, that is 3 times this vector, and everything is falling in place. I hope you are understanding. Next, matrix. Next matrix for which you are supposed to find lambda values. A is 0, 0, 1, 0, 4, 0, 9, 0, 0. Now It is not that as good as the first one, but not bad also. Find lambda values and corresponding lambda vectors. I mean eigenvectors. Lambda 1 is equal to 4. Eigenvector is 0, 1, 0. Simple. Now, determinant of this matrix is minus of 9 into 4 into 1, because you have to expand it using last this 1 into 0 minus 9 into 4. That is what is minus 9 into minus of 9 into 4 into 1. So determinant of A is equal to minus 36, out of which this is lambda 1, lambda 2, lambda 3, correct? Lambda 1, lambda 2, lambda 3 is minus 36. Therefore, lambda 2, lambda 3 is equal to minus 9. And trace is equal to 4, which is lambda 1 plus lambda 2 plus lambda 3 is equal to 4. So, lambda 1 plus lambda 2 should be equal to 0. Sorry, lambda 2 plus lambda 3 is equal to 0. That implies lambda 2 is equal to 3, lambda 3 is equal to minus 3. Okay. So if you use lambda 2 is equal to 3, your matrix becomes minus 3, 0, 1, 0, 1, 0, 9, 0, minus 3. Okay. And now you are supposed to find out the proportion in which you need to mix vector, first vector, second vector and third vector to get 0 vector. And it is very obvious that you take this 1 times, you take this 0 times, and you take this 3 times. And then if you add, all the 3 vertical columns are going to be 0, 0, 0. So for lambda 2 is equal to 3, our eigenvector is 1, 0, 3. Okay. And if your lambda value is minus 3, then the entries would become 0 minus minus 3 is 3, 0, 1, 0, 7, 0 and 9, 0, 3. Okay. If you look at this, you take this 1 and you take this minus 3, it will become 0. Therefore, eigenvalue for this is 1, 0, minus 3. These are the eigenvalues and eigenvectors of some odd diagonal matrix, 1, 4 main diagonal position. अरे थोड़ा थोड़ा समझते का? What would be the eigenvalues? What will be the eigenvalues of this matrix? 2, 4 minus 2, 3, 1 minus 3, 0, 0, 10. Find eigenvalues. Now, 0, 0, 10 implies first eigenvalue is 10. When you take transpose, the eigenvalues will continue to remain the same. So, value is 10. Now, you can see that the columns add up to 5. Therefore, lambda 2 is equal to 5. And then trace is 13. So, lambda 3 is equal to minus 2. These are the 3 values of eigenvalues of matrix A we have found out without doing any calculation, fraction of second. Okay, and maybe corresponding eigenvectors also you can find out, but then we will have to do that subtraction and evaluate that. Let us see if for one we can do it or not, because now we are learning a technique by which eigenvector can be found out very quickly. So maybe for lambda 2 we will check minus 3, 4, minus 2, 3, minus 4, minus 3, 0, 0, 5. Okay. So now what vector we should multiply this with so that we get 0, 0, 0. Now if we make this entry 0, that means add these two. So 3, 4, minus 2, 0, 0, and you add that 2, minus 5, 0, 0, 5. Is that right? Okay, so you want to make sure that you get first 0. Can you suggest what should be the linear combination? 4 times this plus 3 times this plus 0 times this. Will it give us 0, 0, 0 every time? Yes or no? 4 3 12, 4 3 12, 0. So if I multiply this vector by 4 3 0, I get 0, 0, 0, 0, 0. So this is my eigenvector for corresponding value of 5. 5 is 4 3 0. It is easy, very easy. I mean, if you just do row reduction without creating a pivot, etc., you have to get the judgment of that linear combination, what you want to make this column 1, how much times column 1 plus how much times column 2 plus how much times column 3 on the subtracted, lambda subtracted matrix. We should end up getting 0, 0, 0, and therefore this matrix multiplied by this will produce 5 times this. This matrix multiplied by 430 will produce 5 times 430, that is 20, 15, 0. Okay, so everything is working fine. Next, now let me give you first 5 by 5 and then the final one which we had written in the beginning. Now this is your demo 5 by 5 where blockwise decomposition I am going to explain a bit, not in detail. Suppose you have 5 by 5 looking like 1 2 3 0 0 2 4 6 0 0 10 20 30 0 0 0 0 0 1 2 0 0 0 2 1. Okay. Maybe I give you some time to find out eigenvalues of these, and eventually we will find out eigenvalues and eigenvectors of these. Maybe the last one eigenvector we will not find. Find 5 eigenvalues and 4 eigenvectors. Sure, I'll wait for some time. See, majority of the entries here are rectangularly 0, 0. So you need to consider this block of matrix, first block of matrix, which we have already worked on. And this is something which is new. Okay. So, as far as this matrix was concerned, the first one, our eigenvalues were lambda 1 is equal to 0, lambda 2 is equal to 0, and lambda 3 is equal to 35. That is what were the lambda values for the first matrix, 3 by 3 matrix. Okay, and their corresponding vectors were 2 minus 1, 2 minus 1, 0 at that time. Lambda to 0, it is 10, 0 minus 1. And for 35, it was 1 to 3. Right? So there is no much change in this. If this is a special matrix 5 by 5, where you don't have these 6 and these 6 entries 0, 0. So if I consider the lambda value for the first 3 by 3 matrix as the lambda value for capital A here 5 by 5, which is equal to 0, then the only change I am required to do is, instead of making this column vector 3 with 3 components, we need to make it with 5 components, because we don't want these 2 columns to disturb our calculation. We don't want to these last two columns to disturb our calculations. We are imparting 0, 0 to them. So now if you use lambda 1 is equal to 0, that means if you multiply this entire 5 by 5 bracket by this column 2 minus 1, 0, 0, 0, you will end up getting 0, 0, 0 matrix in RHS. So this is your first eigenvector. Lambda 2 was 0, and then corresponding 5-dimensional 10, 0 minus 1, 0, 0 is going to be eigenvector for this. Because of the last two zeros, these two entries are not disturbing. Lambda 3 is of course going to be 35, and the column vector 1, 2, 3, 0, 0 will work. It will give us 0, 0, 0, 0, 0. Now we are left with two more values, lambda values, for which you need to consider this 2 by 2 matrix as independent matrix and find out the lambda values for this 2 by 2, and we will represent it as 0, 0, 0 and whatever the entries for this matrix is. Okay, that is the simple trick, because this is a special matrix. Now here rows add up to 3, both the rows add up to 3, and therefore lambda 4 is going to be 3, correct? And if you subtract 3 from both of them, we get minus 2, 2, 2, minus 2. So 1 times this plus 1 times this add up to 0, 0, and therefore your only 2 by 2 if you are considering, it is 1, 1. Matrix will make it 0. Now lambda 4 also we got. Total there are 5 lambda values. So let us consider the trace now. Trace is equal to 35 plus 2, 37, and we have got total lambda values 35 plus 3, 38. Therefore lambda 5 is equal to minus 1. Now if you consider minus 1, okay, let me write down these 5 by 5, I mean 5-dimensional vectors here. 0, 0, 0 for first 3 rows, then we have 1, 1. That is your vector number 4. This is vector number 3. And for minus 1, what we have is 0, 2, 2, 0, and 1 minus 1 is the eigenvector 0, 0, 0, 1 and minus 1. So even if it was 5 by 5, little special, but we could deal with all 5 eigenvectors and eigenvalues by these simple tricks that we have learned. In fact, we have found out all the eigenvalues I wanted. Okay, next problem is the problem number 1, which was given to you in the beginning. With this kind of training in this lecture, are you able to find out all possible eigenvalues for this matrix 13070 26030 00650 515 0 minus 9 0 3 9 0 minus 1 minus 10 and 9. This is our A. Find all eigenvalues or find 5 eigenvalues and 4 eigenvectors.
Excuse me, sir.
Yes.
Can you zoom?
Now, first observation is the column number 3, 0, 0, 6, 0, 0. So 6 is in correct position. Therefore, first eigenvalue is 6 and corresponding eigenvector is 0, 0, 1, 0, 0. That is done. If you look at fifth column, 9 is in a correct position. So lambda 2 is equal to 9, 0, 0, 0, 0, 1. Second, third observation, all the rows add up to 11. Yes or no? Yes. Lambda 3, 11. Corresponding vector 1, 1, 1, 1, 1. Okay. So these are the first three observations. Then you observe that first column and second column, they are multiples of each other. They are not really linearly independent. So you can, so if that is the case, the determinant of capital A is 0, and if determinant is 0, the lambda raised to 5 plus something into lambda raised to 4 plus something into lambda raised to 3 plus something into lambda raised to 2 plus something into lambda raised to 1 plus something, this is going to be 0 because determinant is 0. These two rows are multiples of each other. Therefore, determinant is 0 and hence one root is definitely lambda is equal to 0. And you can achieve the vector corresponding to that by multiplying first by 3, first column by 3 and second column by minus 1, remaining 0. This is going to be your fourth vector. This is v1, vector 2, vector 3, vector 4. Now we are supposed to find out lambda 5. Who will help us? Trace will help us. Minus 9 plus 9, 0, 13. Trace is 13. And what is the addition of all our lambda values that we have got? 26. Okay. So lambda 5 is minus 30. Okay. And if you are really interested in finding out the corresponding vector of minus 13, we will have to follow the procedure. We will have to follow the procedure and we will get it. But then that is not expected out of 5 by 5. There will be a column vector which will be corresponding to lambda 5. So 5 by 5 matrix, you quickly found out all the 5 eigen values for that matrix with proper systematic understanding of theory. Matrix A was 2 by 2, 5 minus 2, minus 2, 2. Okay, and we had found out the eigenvectors of this matrix and eigenvalues. So can somebody tell me what are the eigenvalues and eigenvectors? These are eigenvectors v1 and v2. If my notebook is saying correct, can you confirm, are these eigenvectors for this matrix minus 2 comma 1? So if I get minus 2 comma 1, that is minus 10, minus 2, 12, minus 12 and minus 6, minus plus 6, yes. And this is 5 minus 4, which is 1, and minus 2 plus 4, which is, so this is, I think, minus 6, and this is 1. So minus 12. So this
It was
is
six.
corresponding to 6, and this vector is eigenvalue corresponding to 5 minus 4, 1. Is that right? So these vectors are correct. So I put them here and I try to multiply a multiplied by x is equal to, that is what you find out, which is easy. And then after you do that, I want to take minus 2, 1 here and 1, 2 here and multiply it, post multiply it by ABCD. Get me matrix ABCD. Get me this matrix. Find this matrix. So first you are supposed to multiply these two, get this matrix, and then what values of ABCD should you put here, so that after multiplying it with this X matrix again, you get back to the original. Surprisingly, you will find that these 4 entries are known to us. They are familiar. First column vector was corresponding to 6 eigenvalue and it was eigenvector, and that is where this fellow sits, 6. Second eigenvector was corresponding to 1, which goes here, and you will find that this vector is minus 12 plus 0, so this is minus 12, this into this, okay, so 0 into this is 1, this is 2, and this is going to be 6, multiplication is this, and you got, I mean, those lambda values are sitting at the diagonal elements. Let us cross check now. We have had one more 3 by 3 matrix, 1 minus 1 0 2 3 2 1 1 2. This was our matrix whose lambda values we had found out, and eigenvectors also we have found out. So this is our A. Corresponding to lambda value 1, your eigenvector was 1 0 minus 1. Corresponding to lambda value 2, your eigenvector was minus 2 2 0, and corresponding to lambda value 3, your eigenvector was 1 minus 2 minus 1. Correct? Is this equal to? You will get some product here which we think that it should be 1 minus 2 1, 0 2 minus 2, minus 1 0 minus 2 times 1 2 3 0, 0, 0, 0, 0, 0. Cross check this, multiply these two, check whether you get this, multiply these two, check whether you get exactly same. That is where we are going to stop for the day.